Alright, welcome to video 3. Like I said in the last video, we're going to be learning out linearization in this video, so let's get right into it. Like I said last video, the slope of a position versus time graph should have meaning. For example, in the case where it's just a straight line, it is meters per second because when we divide the units, we give velocity, right? But then I introduced to you the case of a parabolic graph. You can't really take the slope of a parabola because it keeps changing. For example, like I went through some of these examples last video. Here it might be 0.5, then here it might be 1, and then it might be 2. It keeps changing. It's not the same. So how can we get the slope, or at least something meaningful from this? Linearization. Linearization is actually surprisingly, actually a fairly simple concept. I'm going to erase this graph here first. Actually, I didn't need to do that. I'm going to just do this. Let's say I happen to have a position which is time. It's just something simple. I don't know. I'm going to make up some very simple points here. This might be 1, 1. This might be 2, 4. This might be 3, 9. I think you get it at this point. Basically, it's like, this is just y equals x squared, right? Or at least x is equal to time squared. Whatever. So, the process with linearization in this case is we're going to make it so that the graph, instead of a parabola, looks like a straight line. And the way we're going to do this is we're going to square all of the x-coordinate values, which in this case is the time values, in order to linearize. So because of that, now on the x-axis, we actually have time squared. So then that's going to have units of seconds squared now. And now my 1, 1 point still stays the same because 1 squared is still 1. But then my 2, 4 point happens to change. In this case, I go from 2 to 2, 4 to 4, 4 because 2 squared is 4. That's probably about there. 4, 4. I can use really similar reasoning for my 3, 9 point. Instead of 3, it's going to be 9 now because 3 squared is 9. Then I have the point 9, 9. And now I can put a best fit line. Now we can take the slope of this. Why does this give us slope? Because, again, like I said, we can look at the units. The position has units of meters. This, like I said, has units of seconds squared. Meters divided by seconds squared. That looks awfully familiar, doesn't it? Yeah, it's acceleration. However, there's something important to note with acceleration. You might take you might take this line and see slope is 1. It's pretty straightforward. This is just an x equals t graph. Technically t squared. Forget it. This is just a linear line with a slope of 1. So you might be tempted to say the acceleration is just 1. This isn't quite the case, though, because if we look at our UAM2 equation, we have change in x is equal to 1/2 at squared. I'm going to ignore the v naught t term for this. This 1/2 at squared term is the important part of this. If I happen to multiply both sides by 2, I get 2 times change in x is equal to, whoops, not yet, is equal to at squared. Then I can divide both sides by t squared to get 2 times change in x over t squared is equal to a. However, the key part here is that this change in x over t squared, this is the slope. So this actually becomes the slope, let me change colors. 2 times the slope is equal to the acceleration. So, like I said, the slope of my linearized graph is 1, but the acceleration isn't 1. If I take my value of slope from up here and into this equation, then I get that a is equal to 2. So then I can say that the whatever this object is accelerating at 2 meters per second squared. This is the way of linearization. You take this parabolic graph, then you linearize it by, in this case, squaring all of the x-coordinate values to linearize. In this case, though, you need to double the slope of your linearized graph to get the acceleration. That is the important part. Don't forget that. Now, here you might be wondering to yourself, why are we squaring? Like, why squaring specifically? Sure, you can look at this from a unit perspective of units, but there is a more obvious, well, not obvious, but there is a more clear answer that lies in proportionality. I'll get into that next video, and I'll see you there.